Alright, today we're going to be going over elementary functions. So there's going to be two main things we're going to be doing today. One is that we're going to familiarize ourselves with a few basic equations, and then we're going to try to manipulate them and learn how to manipulate them. So in the first example that we're going to be looking at is if f of x equals x, or the identity function. And if we were to graph the identity function, y-axis and x-axis, the identity function cuts through the origin at a 45-degree angle, and that will be our f of x equals x function. Note the domain of this function is all the real numbers. So when it's talking about the domain, we're talking about all the possible x values such that there exist y values. So for all possible x values, there exists a y value. So that we're talking about the domain, and we're talking about the range. We're talking about all of the y values that exist during this function. Alright, so that is the identity function. If we look at this next equation, g of x equals x squared, if we were to graph that one, it would be this parabola shape that just barely touches the origin. And it has this like big old U shape. Note that the domain of this function is all real numbers once again. For every single possible x value, say one x value way out there, there's going to exist a y value for this function. When we talk about the range of this function, we're talking about all the y values that exist in this function. And note that we don't have any y values below the origin, so that's why the range is from 0 to positive infinity. Alright, so that is the x squared function. So let's look at x cubed. And this is going to be this funny looking guy cutting through the origin, this little squiggle. And once again, if we want to talk about the range of this function, it's going to be all real numbers, because that for every single x value, there's going to exist a y value that corresponds with it. And then when we talk about the range, once again, it's going to be all real numbers, because there exists a y value for every y value. For every y value, there exists a point on this function. Alright. We're going to talk about n of x equals the square root of x. That function starts at the origin and kind of is always increasing, but increasing at a decreasing rate. So that's what that function looks like. And note, when we talk about the domain of this function, it's going to be 0 to positive infinity, because there are, for all these negative x values, there's no y values that correspond with it. And similarly, when we talk about the range of this, it's going to be 0 and all positive y values, because there are no negative values of this square root function that this function exists for. Alright, when we talk about the cubed of x, note that this is, let's go back to x equals the square root of x. This is also n of x equals x to the 0.5. Well, the cube root of x is the same thing as saying e of x equals x to the 0.333, repeating 1/3. Alright, and this function looks a little bit like x cubed, but it's going to be on its side. It cuts through the origin. Once again, the domain of this function is going to be all real numbers, because for any x value you can think of, there's going to be a y value that corresponds with it. And similarly, the range of this function is going to be all real numbers, because for every single y, there's going to be a value of that function that is valid for. Alright. Last but not least, we're going to be looking at h of x equals the absolute value of x. We would graph that function. It is this v guy. Once again, the domain of this function is going to be all real values, and the range of this function is going to be only from 0 to positive infinity. There are no negative y values such that this function exists for. Alright, so we have gone over all of our, what we're going to call fundamental or elementary functions. We got the identity function, x squared function, x cubed function, the square root of x function, the cubed root of x function, and the absolute value function. So now we're going to look into transformations. How can we take our original function and then do some basic manipulation to it? So let's look at transformations of this f of x equals x squared function. So let's graph what f of x equals x squared function looks like. And that is f of x equals x squared. Alright, so let's go over some basics. So like, let's say we have f of x equals x squared plus k. And then let's do this for k equals -4, 0, and +2. I'm doing in different colors because I want to be able to represent these on the same graph and be able to represent them by color. So if we want to do that middle one first, here is f of x equals x squared plus 0. That is our original function. Now if we want to do this k equals -2, that is going to be a vertical shift downwards of our original function 4 units downwards. So if we go 4 units down, 1, 2, 3, 4, all we're doing is doing a vertical shift downwards of 4 units. So this is f of x equals x squared minus 4. And then if we want to do f of x plus 2, all we got to do is shift the original black line up 2 units. So this would be f of x equals x squared plus 2. So note that whenever we are plus or minusing k, all we are going to be doing is doing a vertical shift of our elementary function. Our elementary function was simply f of x equals x squared. If we are adding or subtracting some number to our elementary function, all we are doing is doing a vertical shift up or down of the k value. Alright, so let's think about horizontal shift. So if we have f of x equals to x plus k squared, and let's do this for similar values for k equals to -4, 0, once again +2. So now we are adding k to the x. So we're not adding k outside of the elementary function, we are adding k to the x term. And then this may get a little counterintuitive for a lot of students. So if we originally were to graph, this is f of x equals to x squared, or plus 0 for our k, that is our elementary function. If we want to do the f of x for k equals -4, what we're going to do is shift this horizontally to the right 4 units. 1, 2, 3, 4. And then redraw our elementary function. So that is f of x equals to x minus 4 squared. So whenever we are minusing a value to our x term variable, we're going to shift it to the right 4 units. We're not going to shift it to the left 4 units, we're going to shift it to the right 4 units. And then similarly, if we were to work with k equals +2, we're going to shift our elementary function to the left 2 units. And that is our f of x equals to x plus 2 squared. Alright, so let's do f of x equals to a times x squared for a equals to, let's just do 1, 4, and 1/2. So a little bit different numbers, but still we're going to be manipulating our original f of x function. So we're going to have, let's do -1/2 instead of +1/2. Alright, so our original f of x function is x squared. So this is f of x equals to x squared times 1, or just our original f of x function. So let's work with this +4. So that is going to be a positive value and it's greater than 1. Given that it's greater than 1 and it's positive, that means we are going to kind of like tighten up our distribution. It's going to grow 4 times as fast. So this will be f of x equals to 4 times x squared. So it's going to grow twice as fast. Now if we're dealing with that -1/2, that means it's going to grow half the speed. So it's going to be much fatter. And because there's a negative sign, it's going to be flipped around the horizontal axis, or the x-axis. So it does two things. It flips around the horizontal axis and it grows at half speed. So this is f of x equals to -1/2 x squared. So it's important to note that we have vertical shifts, horizontal shifts, and we got to deal with our a term. What are we multiplying our function by, our elementary function by? So let's do a couple more examples that combine some of these things together. So if we have an elementary function of f of x equals to the absolute value of x, if we were to graph that, that would be our elementary function. Now if we were to ask to graph y equals to -x minus 3 plus 1, note that there are a few things going on right here. We're going to have a vertical shift of 1 unit. We're going to have a horizontal shift to the right 3 units, and it's going to be flipped around the vertical axis. So if we were to shift this whole thing up 1 unit, we're also going to have a horizontal shift to the right 3 units, 1, 2, 3, and we're going to flip this around have this facing the opposite direction. Let's do another example. If we have f of x equals to x cubed, And so we wanted to graph the elementary function. That is our elementary function. And now we want to say graph the function y equals to negative x minus 5 cubed. Well, once again, that's going to be there's no plus or minus some value on the outside, so our vertical shift is 0. Our horizontal shift is to the right 5 units, and it's going to be flipped. So if we wanted to graph this, we would shift upwards 0 units, so there's our original starting point, and then we're going to shift to the right 5 units, 1, 2, 3, 4, 5. And then if we were to flip the function, it would look something like that. Alright, let's do another example. Lots of examples today. So if we have our original elementary function is f of x equals x squared, that's our elementary function. And say we wanted to graph the function y equals to 5 times x plus 3 plus 4. Once again, we're going to have a vertical shift of 4 units. We're going to have a horizontal shift to the left 3 units. And it's going to grow 5 times as fast. So let's first do the vertical shift. So we're going to shift it up 4 units. 1, 2, 3, 4. Then we're going to shift it to the left 3 units. 1, 2, 3. And then it's going to grow 5 times as fast. So it's going to be a tighter looking function. It's not going to be really wide. It's going to be really thin. So this would be y equals to 5 times x plus 3 plus 4. Do another one last example where if we have our original function, which might be y equals square root x, and we were asked to graph that. That starts at the origin, increases, but it increases at a decreasing rate. And then let's say we'd be interested in graphing y equals to negative 0.3 square root x plus 2 plus 2. So once again, we're going to have a vertical shift upwards 2 units. We're going to have a horizontal shift to the left 2 units. And it's going to be flipped. And it's going to grow at 1/3 the speed, or 0.3 the speed. So let's shift this up 2 units. 1, 2. That's representing the vertical shift right here. Let's shift this to the left 2 units. That would represent this plus 2 right there. 1, 2. And then we are going to have this function go downwards instead of upwards. So instead of going up like that, it's going to go downwards, and it's going to go downwards at a slower rate than the original one. So if this was just a -1 here, we might have our flipped equation grow at the normal rate, such as our first one did. But because it is 0.3, it's important to note that this is growing at a slower rate. Alright, so that does it for today.